Number 66. Figure 2.68 shows the position graph for a particle for 5 seconds. Draw the corresponding velocity and acceleration graphs. Okay, so we have a position versus time graph here. Now, somehow we have to, from the position versus time graph, create a velocity versus time graph, and then create an acceleration versus time graph. Okay, so the first important step will be, how do we go from position versus time to a velocity versus time? Well, in order to figure that out, let me just erase this stuff. In order to figure that out, we have to understand how position is connected to velocity via the graph. So recall what slope is. Slope is the change in y over the change in x. So what in this graph, in position versus time, what are the units for the y-axis? It would be meters. What are the units for the x-axis? They would be seconds. And in physics, what do you know meters per second to be? Right, velocity. So the slope of the position versus time graph is the same thing as the velocity. So what I need to do here is I need to find the slope of this graph. Now it looks like the lines are all over the place, right? And they are, but that's fine. We have to treat this as like a piecewise function, or essentially a graph that will have 4 pieces to it. I think 3 comes after 4, right? Yes. Okay, so we have 4 pieces. Okay, so I'm going to dot the points in between each piece. Okay, beautiful. Now what? Just to clean it up a little bit, let me just erase these numbers here. Okay. All right, so we got the 4 pieces, and I'll include the dot for the end mark as well. So let's consider this first segment, segment number 1. What's the slope? Again, remember, so I'll call this segment 1. What's the formula? Well, slope is equal to change in y over change in x. Expanding on that, it would be y2 minus y1 over x2 minus x1. Okay, wonderful. So what that tells me is that I need 2 points. Well, I already dotted them, this point and this point. So what are the coordinates of this point? Right, it would be 0, 0, right? The x value is 0, the y value is 0. So let's call this one x1 and my y1. What are the coordinates of this point? Well, it has an x coordinate of 2 and a y coordinate of 2 as well. So it'd be 2, 2. Let's call this the x2 and this one the y2. Wonderful. And now all we have to do is plug them in. So my y2 value is 2. My y1 value is 0. My x2 value is 2. And my x1 value is 0. So 2 over 2 is equal to 1. So 1 meter per second would be the velocity over, so let me write this, over the first 2 seconds. Okay, great. Let's look at segment 2 now. All right, so segment 2, we're going to be looking at it from this point now to this point. So we need the coordinates. Again, I need to find the slope from between those 2 points, right? So slope, and I'll call this segment 2, right? So the slope is equal to change in y over change in x. Same thing, the slope is equal to y2 minus y1 over x2 minus x1. So the slope here will be, I need to find the points. So I already found the coordinates here. All right, now let me start with the coordinates here. So this looks like it has an x value of 3 and then y value of -3. Right? So 3, -3. And what I'm going to do is, since I already labeled this x2, y2, I'm just going to call this x1, y1. All right, just so I don't have to keep going back and erasing stuff. So now, when I'm considering those 2 points, right, I said that my my y2 value is 2. My y1 value is -3, so it's 2 minus -3. Divided by my x2 value is 2, and now my x1 value is 3. Okay, so let's see what we get. We get now 5 over 1, right? And specifically -1. Now that should make sense. The slope is negative. It's pointing down and to the left, to the right. So this is -5 meters per second. And that will be equal to the velocity. And that's over the next 1 second. So meaning that from 0 to 2, seconds was my velocity in red. Now from 2 seconds to 3 seconds, right, was my velocity now in yellow here. Let's do the next segment, segment number 3 now. I think you guys might be seeing the pattern. I need to find the points of these two. I already found the points here, so I'm going to keep that. I got to find the point here. What are the coordinates? Well, it looks like it has an x value of 5. And its y value should be the same, -3. Okay, so let's call this, since these are my x1, y1, let's just call this x2, y2. So same thing now. For segment 3, the slope is equal to change in y over change in x. Slope is equal to y2 minus y1 over x2 minus x1. So the slope here is equal to my y2 value, which was -3, my y1 value, which was -3, so it's a minus -3, divided by x2, which was 5, and then my x1, which was 3. So my slope here in black will be 0 over 2, which works out to be 0. So it's 0 meters per second, that's the velocity, over the next 2 seconds. Right? Because the segment 3 went from 3 seconds to 5 seconds. So here we go from 3 seconds to 5 seconds. And now finally, last but not least, let's do segment number 4 here. Okay, we need the 2 points. We already have the coordinates here. So let's find the coordinates of this point. It looks like the coordinates there should be 6, comma, looks like about -2, right? Since these are x2, y2, let's call this x1, y1. And again, segment 4, right? Slope is equal to change in y over change in x. Slope is equal to y2 minus y1 over x2 minus x1. So slope here will be equal to my y2 value, which is -3, and then minus a -2, okay, divided by my x2 value, which is 5, and my x1, which is 6. Okay, great. So how do the numbers work out? So the numerator is going to be a -1 divided by a -1. So the slope here becomes +1, right? Or just 1 meter per second. That's the velocity. Okay, and this is over the next second, right? 1 second. Because we went from then 5 seconds to 6. Okay, great. So we got all this stuff going on. All right, so now we have enough information we need in order to finally graph the velocity versus time graph. All right, so let's draw an axis. I'm going to draw it on the upper left. Okay, let's draw something that looks like this. Okay, so let's put in some markings here. Say this is 1, 2, 3, 4, -1, -2, -3, -4, -5. That should be good enough. Okay, so I also need my x, right? Let's call this 1, 2, 3, 4, 5, and then 6. That should cover all the time. Okay, so now for my first segment, right, from 0 to 2 seconds, what was the velocity? We calculated it to be 1 meter per second, right? So go to 1 meter. So remember, I should have labeled the axes. Remember, this is the time axis, and this is now my velocity axis. Okay, meters per second. So go find 1 meter per second. That's right here. And draw a line that represents 1 meter per second for 2 seconds. It would look just like that. Let me actually autocorrect so it comes out nice and straight. There we go. I'll make it a little longer. Okay. I don't see the difference, but okay. So next thing what we're going to do now is we're going to take a look at the next segment, right? So what's the next segment? Well, the next segment occurs from 2 to 3 seconds, right? So just the next second, and its velocity is -5. So locate -5 on the graph. So here it is. Now what you have to do here is draw a line down, straight down to -5. And that's not exactly straight. Line straight down. Okay, that'll do. And now what we have to do is for the next second, make a straight line at -5. So we have something that looks like that. Okay, great. Now, moving forward, let's find now the next interval, or segment 3. It says that on segment 3, the velocity was 0 meters per second, and that occurs from 3 to 5 seconds. So now what I need to do, go back to the velocity graph. I need to now draw a line straight up to where the velocity is 0. So the velocity is 0, remember, right at the x-axis. So I have to draw my line straight up. So it's going to come right up to 3 or so. Okay, great. And now it's going to be, I have to represent now 0 velocity for 2 seconds, right? Or from the time of 3 to 5. So it looks just like that. Okay, great. We're almost there. We just got to do one more segment. Okay. And now, for the last segment, right, take a look. So over the time interval 5 to 6 now, what's the velocity? The velocity is 1 meter per second. Okay, wonderful. So let's do that. So we got to go back to our velocity graph, draw a line up to about where 1 second is. So it looks like it's about there. And now draw a line right on over. And it looks like it goes to there, right? Okay, so that is perfect, and it looks like now the graph has stopped, right? There's no more continuation. So what we could do from here is we could leave the graph like this, or we could bring the line back down to the starting point, because if I assume that the object, looking at the graph in the upper right-hand corner, if I assume that the object stopped here, then I know that the velocity should have been 0. So I can just bring this back down if I like. All right, so now I just graphed the velocity versus time graph. And this is exactly what it would look like. Okay, now all we have to do is the acceleration graph. So let's erase everything. No, we're not going to erase everything. It's actually going to be a lot faster. Why? Well, remember, if I were to create an acceleration graph, I would have to create it understanding the slope of my velocity graph. But what's the problem with some of the slopes here? Like, what's the slope of this line? It's not 0. It's undefined, right? It's undefined because if I think about what slope is, m is equal to change in y over change in x, right? From this point here, I'll dot it, from this point here to this point here, how much does the x value change? Meaning, what's the x value of this point? It's 2, right? What's the x value of this point? Well, it's also 2. So if in terms of my formula here, if I plug in 2 minus 2 in the denominator, what does that become? Well, it becomes 0. And what happens when 0's in the denominator? It becomes undefined. So you really can't even draw an acceleration graph for this, right? I do know at certain points the acceleration is 0, and then here it's here for this path it's 0, then for here it's 0, then for here it's 0 because there's no change in velocities over that time. But when the velocities do actually change, they're undefined changes. They're not smooth, continuous changes. So therefore, we can't really even graph the acceleration graph. So, doesn't feel satisfactory, especially since this is the last problem in the chapter. I always like to end on a bright note, but it seems like that's going to be the case, guys. So, thank you so much for tuning in. This concludes chapter 2. We have a lot more coming out, so please stay tuned. And please do remember to subscribe. It definitely helps us out tremendously, and it'll enable us to keep helping you guys out. So thank you so much.